Hello and welcome to our today's webinar, continuing along the theme that we've had previous sessions on around visualization and analytics. Today we're going to focus in on gaining insights in real time through location intelligence. You've already heard from Noel, and I'm Ben Conklin, and I'm joined by Armando Drain. And we're going to take you through the GIS products that help you manage real-time data, visualize real-time data, and analyze real-time data as an overview today. To start with, I think it's important to think about our world in context. And I appreciate many of you for being here today with such a difficult day we had yesterday in the US, a difficult day for our country. As we look around the world, we have many of these challenges on a daily basis of increasingly dynamically, increasingly complex and difficult issues that we must deal with. And it's really making it difficult to understand and appreciate the connectivity of the world. We live in this connected world where decisions and actions and activities have an impact on everything we do. We are increasingly connected. We are way beyond just computer systems and phones. We have now devices and sensors that are very diverse. Soon there's going to be over 20 billion connected things in the world. And while many of these things might be consumer focused, many of them are also used in businesses and the government and in the functioning of our society, and are helping us create this digital living twin of our society. GIS helps us integrate data and abstracts this kind of data as geography. And fundamentally, GIS provides us a framework and a process for integrating analysis and modeling, planning and design, decision-making, and ultimately taking action. And this GIS framework can work with real-time data in addition to static data. So why would you want to use a GIS in order to manage and you work with your real-time data or sensor data? Well, you use it for three different reasons. It's really, GIS is very good at linking and combining information, and we can use it to perform visualization and analytics. A GIS can dynamically link out from a data set or an object on the ground, it can dynamically link out to other records or other systems. When you put data into a GIS, you're able to visually overlay that data so you can actually see the data in context of its location relative to other data. And you can also perform analysis across data sets and bring those together through dynamic processes and not having to store all your data in one system or one database, but actually bringing it in dynamically. And the GIS is able to integrate many types of data and multiple formats of data and makes those data sets directly usable as services. So you can bring in unstructured data, tabular data, you can bring in imagery data, and of course, this real-time data, which is going to be the focus of our discussion for today. And you can integrate that data into simple web maps, layers, and scenes. Ultimately, having that data integrated in such a simple way into these maps, layers, and scenes then lets you deliver data through a variety of powerful applications. Robust GIS mapping projects, get into data science, into analytic tools, and you can share that data out to decision makers through tools like dashboards, which we're going to see later today. So inside of ArcGIS, we have a framework for integrating real-time data into the system in order to make those services like we were talking about before. And this requires kind of a special kind of framework because real-time data comes in a variety of formats and it comes in feeds and streams. And so what you really need is to have a back-end system that runs in the cloud or in your enterprise on hardware that you own that can connect to these feeds, process the data quickly, and push it out to a variety of applications. And the way that we will see that come to life today is through a couple of products. So we have Geo Event Server and Geo Analytics Server, which are the server products that run on your hardware in your own enterprise. And also Arcgis Velocity, which is our new product that's fully hosted by Esri. It's a cloud-native service. It's very fast. It deals with high volumes of data. And you license it as software as a service that you can just log into and access via ArcGIS Online, and that will let you build out your own capabilities without hosting services on your own enterprise. So you're going to see these real-time processes today, so tools for processing data, tools for analyzing data, but also applications for visualizing and interacting with data. And we're going to show you a few use cases, but there are numerous use cases for working with real-time data that would apply to government organizations. So things like tracking personnel or status of staff, so field workers, for example. Integrating in with systems like real-time reporting systems like SCADA systems or monitoring current operations. helping to optimize the use of your resources or track specific specialized assets. as well as working with things like monitoring tools and connected sensors or connected cars, or protecting infrastructure from natural or man-made threats. To get started with data, with working with real-time data, you don't even need to stand up a server or even work with server products. You can actually take advantage of the Living Atlas of the World, which is Esri's collection of ready-to-use data, layers, maps, apps, and more. It's categorized for easy search, and it's authoritative data. Within the Living Atlas of the World, we have a collection of live feeds that you can begin to consume immediately. We process and update the data in near real time, and then we provide layers for access across the platform. And we provide authoritative data for a variety of applications, like severe weather, hurricanes, floods, wildfires, earthquakes. There's a variety of live feeds in the Living Atlas that you can actually take advantage of, and you can begin to use in applications immediately. One of those key applications that you'll actually would want to use to leverage real-time data are dashboards. And these dashboards are becoming pervasive. In 2020, I would be willing to bet that every single one of you saw a dashboard, especially early in the COVID crisis. You may have even seen it every day if you were like me. I'm checking into it. The Johns Hopkins dashboard that many of us relied on to get accurate tracking and statistics for the coronavirus spread, and many that of course are still used today. And many, many health organizations and many municipalities in many countries and many cities have been using dashboards to communicate health status. But it can be used for a variety of different purposes and configured by you as an end user, integrated real-time data in order to create specialized products that you can share with your communities. And these, like I said, these dashboards are becoming pervasive, and they're becoming a common way for decision makers, the public, and policymakers to understand data and to communicate and tell stories that helps people drive policies and actions. So with that, that's actually going to lead us to our first demonstration. Armando is going to take us through how to actually just configure dashboards working with a real-time feed of data in order to do that communication and decision making. So over to you, Armando.
Thanks, Ben. That was a great introduction. So what we have here is an example of ArcGIS dashboards that's integrating real-time data. In this case, we're pulling data from one of our partners, Global Incident Map, that collects, analyzes, and geolocates incidents around the world, stemming from terror incidents, bomb incidents, and arrests, for example. What we can do with the ArcGIS dashboards is configure the experience to give us the real information that we need as quickly as is possible. So we can start off by configuring the widgets, as you see here on the right, to give us key indicators of the incidents that we care about. We can create various lists, so as you can see on the left, where we get information about different incidents that are happening around the world. Because of the latest news around the world, we can go to different countries or areas of interest based on our bookmarks. So if we go back to the United States, we can see incidents around the country, such as the incidents in DC, which we can see in the top right. And as we zoom around the map, we get information on just what specifically is in our map view. So we don't get information that is not currently relevant to us. Some of the other things that we can do is utilize filters. So I can select a specific incident that I'm looking for, such as bomb incidents. So now my map and all my widgets are configured to only see the bomb incidents that are occurring. We can utilize country and state filters. So if I was looking at incidents in Belgium, for example, which there aren't any, that will be filtering. And then one of the key filters actually is date selector. So if I wanted to just look at incidents for a specific day, or if I want to see incidents from between last 48 hours, which I'm using by default, or I can see all incidents around the world that have happened within the last week. Utilizing one of these other widgets at the bottom, we can see trends in our data. And we can see incidents going up and down based on time of day. And if there's a specific trend that we're interested in, whether it's going up or down, we'll be able to visualize that here in our dashboard. If we click on one of the items in the list, we get directly located to that incident. And the pop-up shows us a description of that incident. If it's near something of interest, we could have that indicator there. And we could also link out to that specific incident to gain more information if necessary. One of the last things that is really important when you're thinking about creating dashboards with real-time data is how you filter it. So you can do it with those out-of-the-box filters that I showed on the top of my screen, but you can also add filters that aren't necessarily obvious to the user. So in this case, I configured an auto zoom filter, which will automatically zoom to the latest event on my map. So if we have this dashboard displayed in an operations center or in a location that isn't going to be interacted with, you'll always know that the latest location will appear on your dashboard. So how did I configure some of these things? We have the editing mode of this dashboard. So we can see how I can add different types of widgets stemming from additional maps, pie charts, serial charts, gauges, and indicators. And I'll show you a couple of how I configured these. So in this case, this list on my left side, I limited it to 25 records per view. And I wanted to sort it by publication date. So I'll have the latest incident on the top. I indicate what key metrics I want to show. In this case, I'm showing the title and I'm showing the publication date. But if I wanted to, I could also add in the link or the description. For when I actually have a description, that would appear in my list. But something that is more useful would be what I would be pulling in some like the URL or maybe the category of that incident. And then lastly, in this indicator, we're able to decide what happens when we click on it. So in this case, I want the indicator to zoom, to flash, and to show a pop-up at that location. One of the other things that was useful here is our widget to be able to embed content. So as you can see at the top, we have key times around the world. So we have time in Kabul, we have time in Beijing, and we have Zulu. And this was created simply by configuring HTML in this embedded content. And if I want to modify it, I can easily just delete what I don't need and then save, and everything will appear as you can see here on the right. One of the other filters that I showed earlier was this auto zoom, which it's out of the box, but it takes a little bit more work to get completed. What I indicated here using my selector is labeled on as my default indicator, sorted by publication date, and then I'll just limited the categories to one. So what that means is that it'll select the most recent record and only the most recent record. And by doing that, we could have it flash and pan. But if I also wanted to show pop-up or zoom, we would be able to do that as well. And now that I finished editing my list, I can hit save. And then anyone that has access to my dashboard would be able to visualize and then see the updates that I made. One more thing that is coming and is actually available right now in ArcGIS Online is the dashboards beta. So in this case, I took that dashboard that I showed just previously, and I started to incorporate some of the new features within ArcGIS dashboards beta, which includes Arcade. So as you can see here on the left, we have the list of the incidents, but what we're highlighting here are the terror incidents specifically. So when we have terror incidents in our dashboard, the ones that are highlighted here in red will pop out and be more visible to the user. And then lastly, the other thing that we modified was utilizing Arcade. We were able to create trends of the data so we can see whether terror incidents are decreasing or increasing from the previous day. And as you can see, the terror incidents have decreased by 75% and the bomb incidents by 48%. And with that, I want to give it back over to Ben so we can continue on with the next portion.
Thank you for that, Armando. It was a great demonstration of of a dashboard that you've configured to work with a real-time data feed. One of the things I want to point out what Armando was doing is he was accessing a feed that was already essentially available in ArcGIS. He configured a global activity feed. There's many real-time feeds, both available on the internet from a variety of providers, but also available through ArcGIS through the Living Atlas. And as a user, you can just simply take the dashboard application and configure it to work with those real-time feeds. And that's essentially what Armando was showing us. And that's what we got to see here. And as he mentioned, there's new versions. The dashboard software is being updated all the time. We have a new version of the dashboard coming out with a lot of really exciting new features, including some additional high-end mapping support for kind of special mapping and symbology capabilities, as well as support for a scripting language called Arcade, which is something you use to program against in ArcGIS that lets you do advanced display and symbology options like he was showing in that latest example, as well as a variety of different data sources it can access. So as he mentioned, you can access that version in its beta form currently, and then it'll be released shortly. But even the current version of dashboard, as you saw, that's already available today, can be used for a lot of this real-time data visualization and analytics capabilities. So moving on from just configuring data, let's start to talk about how you actually bring in your own real-time data. So how would you connect to, for example, sensors or streams of data coming from a variety of systems? You would do that using the enterprise products for GeoEvent Server, GeoAnalytics Server, or the ArcGIS Online Velocity. And that lets you integrate real-time data, perform processing on that data, and stream it out to clients like the dashboard. So really, when you think about working with bringing in real-time data, so sensor data or other kinds of real-time data, you really have kind of three major challenges that you need to overcome with working with real-time data. And that's really what the products like Velocity and GeoEvent Server help you do. You need to be able to ingest the data, so connect to it at its source and bring it into your system. You need to be able to alert or cause triggers off of the data based on rules. And you want to be able to analyze the data in stream and in real time. And that's really fundamentally what the real-time products do. So now let's talk about a little bit about how these products work, and then we're going to see another demonstration on how to use these tools. So first off, these tools really help you manage what we call feeds. So feeds are what you set up in order to connect to a data source in order to get data into the system. So you can connect to a variety of data sources. You can connect to data sources that are already in ArcGIS, so like feature services or stream layers. You can connect to popular cloud IoT platforms like Amazon, Azure, or Cisco's cloud IoT platforms, or to standard web and messaging protocols like HTTP, Kafka, RSS, etc. And that's actually really, that ... represents a large variety of formats. When you connect to that data, it'll automatically discover what we call the schema, which is really the rules of how that data is stored and managed. And it lets you then be able to display that data immediately after you connect to it. And then once you have a feed configured, you're able to perform real-time analytics on that feed. So processing that data, and then you can push out to a variety of new outputs. So for example, you might analyze some data and push out to a new feature layer so you can see it in your map. Or you might run some analytics that sends out an email notification. Or you might run some analytics that does actuation, so triggers another system to do something. Much like if you think of as you drive home, if you have your smart light set on, you might turn on your lights as you get close to your house, for example. That'd be an example of actuation. So with that kind of basic principle set up, I'm actually going to turn it back over to Armando, who's actually going to show us that process in action using Velocity. So back over to you, Armando.
ArcGIS Analytics for IoT is the real-time and big data capability inside of ArcGIS Online. It enables users to ingest, visualize, and analyze spatial real-time data and start to do near real-time big data analysis to gain new insights and make informed decisions like they couldn't before. Analytics for IoT can be utilized by multiple sectors. In this case, we're going to look at a national security example where we're looking at current flight locations and seeing how they cross and deviate from certain parts of the United States. To start off, we can connect to multiple feeds such as Azure, Amazon Cloud Feeds, HTTP and Kafka, and other types of WebSockets, in addition to traditional feeds. Like in this case, we're bringing in a feature service from our business partner FlightAware, which tells us where current flights are currently located around the world. In addition to that location, it also tells us its altitude and how fast it's going. To get started with some real-time analytics, we want to know what specific aircraft have crossed over U.S. military bases. In addition to that, we can enrich that data from another feed that has information on the specific countries the different airlines are registered with, which is going to be important in our analysis as well. This information is going to be added to a data layer that's going to be ingested in the operations dashboard. This information provides us individual counts of military base crossings, their current military base name, and what state that military base is located in. We can get aggregate counts to see what military bases have the highest crossings as well. The next step that we want to look at is how long the aircraft have actually been flying over that individual military bases. We can utilize our big data analytics to reconstruct tracks, which will tell us in minutes how long that aircraft has been over individual military bases. In addition to that, Analytics for IoT has other patterns of life analysis such as hotspot analysis, detect incidents, and dwell locations that can be utilized down the road. If we go back to our dashboard, we can see those reconstructed tracks and see that 2 aircraft have been flying over a military base for more than a minute. We can select this one from Italy. We can see that it's been over this specific military base for 5 minutes. The next real-time analytic that we're wanting to do is flight deviations, which is going to tell us when individual flights have deviated from its flight plan. On the fly, we're calculating deviations from flight plans, filtering out the ones that are not of interest to us, such as the ones that are actually landed over LAX, so we can filter those out. The next thing that we want to do is seeing which flight deviations are attributed to weather, and more importantly, which flight deviations are not attributed to weather. For those flight deviations, we're wanting to not only collect that information inside of our data to be visualized in our operations dashboard, but we also want to receive an email when flights have deviated and they weren't specifically affected by weather. We can flag that information and go to our email to see that in this case we have a Chinese flight that's deviated by 3.1 miles, and go directly to that aircraft utilizing operations dashboards URL parameters to see the name of the aircraft, the country, and how far it's deviated from its flight path. Other indicators that we get in this dashboard are how many flights are currently deviating and how many individual flights are not affected by weather that are deviating. We can look at specific aircraft from Taiwan, Korea, or China, filtering those out if necessary from the map as well. We're tracking current Chinese and Russian flights over the US, but we can also filter by airline and country. If we select an individual aircraft, we can filter to that location and see additional information from FlightAware's website. To summarize what we've done, we've been able to leverage Analytics for IoT in the Esri Geospatial Cloud to not just monitor thousands of aircraft, but to also pull out individual planes that have flown over military bases, and in real time received alerts when aircrafts have deviated from their proposed flight plans.
So moving on, let's talk some more about real-time analytics and some of the tools that you have at your disposal when you're analyzing these feeds of data that are coming into the system. So you saw Armando actually leverage a lot of these tools, and we'll walk you through how these work. So first off, you set up and configure your input data sources. So the feeds we were talking about, and that can be one or more feeds. You can also bring in static data sources. So this is actually a really common use. For example, like with the flight data, you might have just the track of a plane, but then you can join that track of a plane with a table that might represent the company that owns it or its country of origin or other data that might not be contained in the feed itself. You can also then use which lets you build a pipeline of one or more tools, and you can analyze each observation individually. And then you can push that data out as layers, as map and feature layers. And you can also use it to configure alerts or notifications, so things like email or other actuation tasks. When we think about the different kinds of data sources for feeds, we have a variety of different input and output types. We can bring in, as I mentioned earlier, feature layers and stream layers. We can connect to standard internet IoT data sources. We can connect to other kinds of HTTP protocols. We can connect to different databases or online storage systems from clouds. And we can push out to a variety of outputs, including other messaging systems and, of course, email and text message in addition to features. And we can also then push out in a variety of formats. So when you configure an output, you can configure the format of the data that's contained inside of that output. And this allows you to do end-to-end analysis. And one of the things that is a really important trend to understand here is we can both do real-time analysis, meaning analysis on individual observations, but we can also connect to and run analysis in a big data system, which lets us analyze across the entire data set. And that will let us do things like large-scale pattern detection or trend detection, and allows us to evaluate incidents versus trends or patterns. On the big data analytics, we can provide that same kind of analytics against the similar data sources. So we can connect to these large data sources, and then we can run large global analytics like analyze patterns, find locations. We can manage and summarize or enrich our data, and then we can push our data back out to a new data set. The kinds of analysis that we can run include what we call spatial temporal analysis, meaning space and time analysis. We can aggregate data. We can bring together tracks, so discrete observations can be combined into a track. We can summarize attributes. We can count things within objects. We can find locations. So things in the find locations category would be useful for activity like pattern of life analysis, like Armando was talking about. We can analyze patterns in our data across all of our data set, doing things like densities and hotspots. We can use proximity. We can enrich our data, which helps us understand statistics about the data. And we can just do management tasks like calculating fields, adding fields, changing the structure, changing the schema, changing the projection, and kind of standard GIS tasks like overlaying layers and merging data. And all of these analytic tools can be applied to any of the streams of data that are coming in. So really what the velocity and real-time data is letting us do is it's helping us to ingest our data, visualize our data, fence our data, detect incidents and trends, and perform alerting. It provides us a guided, configurable user experience, so you don't need to write code to do any of these tasks. It runs in the cloud as a software as a service offering, and it's actually managed by Esri and is built to scale out. When we work with these real-time feeds in Velocity or in GeoEvent on our enterprise, we can connect our IoT platforms, our sensors, or other apps, ingest our data, and push it out to new applications. I'm talking quite a bit. The examples that we've been seeing today from Armando have been with Velocity. The equivalent for running in your enterprise is GeoEvent Server and GeoAnalytics Server. So GeoEvent Server handles the tasks of ingesting data and analyzing data on individual records. And then the GeoAnalytics Server is what does the ingestion and analysis across big data. And Velocity, that's all one single product. So if you're accessing it through ArcGIS Online or on the internet, you would use Velocity, the software as a service offering. If you're wanting to run it in your own enterprise on your own hardware, you'd use GeoEvent Server and GeoAnalytics Server. So with that, I'm actually going to turn it over to Armando for the final demonstration for today.
Thanks, Ben. What we have here is a maritime situational awareness dashboard. Utilizing ArcGIS dashboards, we're able to leverage ArcGIS Velocity to incorporate a couple different things. First, as you'll see here on the map, you'll see a hex bins, which is actually AIS data that we're pulling from our partner Spire. And it's loaded up into these hex bins that actually aggregate all the vessel data, and it all changes as we zoom in and adjust based on where we are in the map and our zoom level. So as we start getting closer to the map, we'll see not only different trends appear, but if we zoom in far enough, we'll actually start to get the individual vessels. And once we do, we can see, if we click on one, the details about it, including the ID, how it was collected, whether it was satellite or terrestrial. And then we can also see timestamps and other unique identifiers about those ships. From that, we actually want to get a little bit more of a focused view of our information. So as I turn off the hotspots for that data, we can start to get a little bit more familiar with what's actually happening behind the scenes. So we're able to track different types of vessels. In this case, we're focused on US Coast Guards that are broadcasting their AIS. We can see on the left that we're able to identify the different types of Coast Guard vessels from the Legend class to Famous and Sentinel class. And then we can also see where they're currently located around the United States. One of the things that's happening on the back end in Velocity is we're able to aggregate and actually enrich our AIS data from a static layer that's telling us where that Coast Guard ship's home port location is. So if I, for example, if I click on one of these records, I can see that this Coast Guard, Thetis, is 283 nautical miles from its home port of Key West. We have its vessels Mimsy, speed, direction, and the last timestamp we've received from that vessel. What's happening in Velocity, it's not only enriching the port, the home port, but we're also on the fly doing analysis to figure out how far away that vessel is from its home port. A lot of the thing that we're doing here is we can see the vessels that have actually transmitted a location recently. So for example, this Coast Guard James, which is located in Charleston, has broadcast its location 8 a.m. this morning, and it looks like it's actually located at its home port right now. And as you'll see as we zoom in, not only can we see the weather warnings, which we've actually received from our Living Atlas, we're partnering with NOAA, but we can also add different layers that add additional context. So as we zoom in, we'll start to get information about bathymetry and maritime charts that can overlay and add additional context to our dashboard. Finally, we can see how many Coast Guard positions we've actually received within the last week, which in this case is 13,888. And all of this was made possible because we leveraged Arcgis Velocity, partnering with our partner Spire for this data, and having this be able to automatically be adjusted in the cloud. So as new ships come, as they come in faster, we're able to handle that information and display that data visually and effectively here in this dashboard. And for those that actually want to figure out or understand how this was built, our next webinar, configuring real-time and big data workflows using ArcGIS, my colleague John will go into detail on how these specific analysis and big data tools are built using ArcGIS Velocity. And with that, I'll give it back to Ben to finish this off. Thanks. Thank you.
Thank you, Armando. So that demonstration was really kind of a great summary of all the capabilities for performing real-time analysis and visualization. And we saw him with this use case where he's able to explore an analytic product in the dashboard, and behind the scenes, Velocity was performing the analysis tasks on the data as it's coming in real time. So I'm having a slight problem with PowerPoint. There we go. All right, and so to summarize, the capabilities with ArcGIS for integrating sensor networks and IoT data to perform real-time visualization analysis. On the back end, to connect to data feeds, we use either GeoEvent Server and GeoAnalytics Server, or we use Velocity, which is our software as a service cloud offering that you can access through ArcGIS Online. And we push that data out to a variety of applications and alerting protocols and make it accessible through the cloud and through the internet to a variety of different clients. So when we do this, when we gain these insights in real time through location intelligence, it helps us provide content and context to support decision making. Helps us see better, helps us change our work, and helps us make us smarter and more effective. So with that, we're going to now open it up to questions and answers. So as a reminder, you have access to the question and answer module. And if you have questions that you would like to ask that you haven't asked yet during the session, please go ahead and type them into the Q&A module. So I'm going to go ahead and pick a couple of the questions that were asked earlier. Some of them we've actually answered, but I think it'll be worth kind of revisiting these. So I guess one of the questions, and maybe Armando, you can help answer this question, was really related to the volume of data that can be handled. So how could you characterize for our audience a little bit about the kinds of volumes and what affects the volume of data that they can handle through both GeoEvent and Velocity?
Yeah, that's a good question. And that there's a lot that goes into that. When you're thinking about the data that you're going to be collecting, you really have to understand, or at least partially understand, the velocity and veracity of how fast that data is coming in and how much data is coming in at the same time. So with like 10.8.1 with GeoEvent server, we've greatly increased the threshold of how many data sets and inputs we can receive at one time. But you'll also need to configure your architecture to support that if you're running on your own servers or on the cloud in AWS or Azure. But with Arcgis Velocity, all of that elasticity and that volume is going to be increased automatically using what we've done with Arcgis Velocity. So it really depends on how big and how fast your data is coming in, whether it's sensitive regarding whether you can actually put the data in the cloud is another key consideration.
Thanks, Armando. That was a great question. And I think that's one of the specific advantages I didn't mention before to Velocity is that scaling and architecture is really happening behind the scenes. It's something that Esri is managing for you, basically. And I think a lot of the other thing I'd also point out in some of the questions was talking about millions of cases a day. So I would just say that's generally well within the parameters of what a server can support. When you start to get to things like millions a minute or millions a second, that's where really specialized considerations are needed for architecture. So that's just a point that I would make. There's plenty of capacity for that kind of use case that was described in the Q&A. Thank you. Another question that came up, Armando, and I'll just let you do kind of a brief answer on this. A lot of people are interested in the global activity tracker. Could you talk a little bit more about the data that was behind that and where you got it and how you accessed it?
Yeah, and we could provide links later on, but one of our partners, they're called Global Incident Map. They have analysts and reviewers that pull in news articles around the world and do the translation and geocoding of that data. And they were able to provide a JSON API that I was able to ingest using GeoEvent in our AWS cloud environment. But the same thing could happen using Arcgis Velocity. It really just depends on what data you want, how much you're willing to pay for it, or your local data sources that you want to leverage. It can all be configured relatively easily and quickly in GeoEvent or in Arcgis Velocity.
Great, thanks. This is an interesting question, and I think the answer is yes, but I would like to see, Armando, what you think with this one is, with GeoEvent and GeoAnalytics, is it possible to track the change of an area's shape or size? So not just looking at the location, but looking at like an area or size case. And I was trying to think of an easy answer to that, but I was just curious what you think is possible there, Armando.
Yeah, that's a good question. You would definitely, there's tools with GeoAnalytics that you could use. I'm trying to think of it, like the overlay or some of the tools that just come inherent in ArcGIS Pro for change detection. You could definitely do that. That would be something that we can follow up if there's a specific question, and I can work with you or some of the representatives for specific your accounts can help you out with that.
Yeah, that sounds good. Yeah, and I think I'm thinking of like the geometry calc. It basically depends on exactly what you're trying to solve. I think there's more than one way to skin that cat, but yeah, it sounds like it's solvable, but somewhat complex. So that's interesting. So another question from Alexis about referencing Spire for maritime data. Do they provide raw data? So they provide a feed that somebody can subscribe to. Is that correct, Armando?
Yeah, we utilize their feed just so we can have data immediately. But I do believe they provide data dumps as well, data of historic data as well.
Yeah, so to be clear, it's Spire, Spire, if you want to look them up. All right, let's see. And another question, can you ingest data coming from ArcGIS Tracker into Velocity?
Yes, because Tracker just generates a feature service, you're able to utilize that feature service as an input and do all the analysis that you can do that you want inside of Velocity. So yeah, that will definitely be possible.
Yeah, that's great. And I think that's a extra kind of good answer is really any data that you can use, any application in ArcGIS that generates data, that data can automatically be brought into Velocity, as Armando's saying, through the feature service connection. So essentially any kind of feature data in ArcGIS can be fed into Velocity. I think with that, I think that's the last kind of questions. I think a lot of great questions that came in there at the end. We appreciate that. So with that, we are going to wrap up. So thanks everybody for coming. And if you enjoyed the session, we have a couple more sessions coming up. As if you've been to our sessions before, you know that we have sessions every 2 weeks. So the next session is spatial analysis and data science. And then following up from this session, they'll be configuring real-time workflows. And so in that session, John Fry, who we work with, is going to get into more detail about how you actually configure these kind of real-time models and analysis. And he's going to build on that demonstration that you saw at the end that Armando showed you. So if you're interested in getting even more hands-on and deeper into the technology, that'll be a great session for you. And with that, thank you all for coming. We really appreciate it, and I hope you have a good rest of your day.